Map reduction. The process of map reduction centers on sound understanding of the type of scale used on the map. The student should remember also that denominator of the scale to be drawn, for example 1/50,000, is bigger than the numerator of the given map. They should note at that point they should reduce such a map. Example, if a given map is 1:50,000, from this example, the denominator of the given map is smaller to that of the new map. Then, the map should be reduced by 1/3, that is 1/3. Important procedures must be observed. 1. Be sure you are actually reducing the map. 2. Be sure to know number of times the map should be reduced. 3. Be careful. Carefully define the new map scale. 4. The given map can be divided into squares of grid lines. 5. Draw the new outline using similar square by means of new scale. 6. Stretch in as much information as might be required to copying such information from the original map given square by square. The information on the new map should be placed same position as they were found in the old map. 7. The title of the map you should have drawn should be carefully written. 8. Transfer the new scale to the map. 9. Determine the new knot with the use of arrow on the right hand side. Map enlargement. Enlargement of a map simply means making the size of a given map larger than the original size. So when you enlarge a map, say twice its original size, the area of the such map has been increased by 4 times. The enlargement has to do with the scale of the map. When the scale of the map to be drawn is smaller than the scale of the original map, then you should know at once that the map must be enlarged. The scale of the original map numerically, that is 1:150,000, while the scale of the map to be drawn is 1:50,000. This means the map should be enlarged 3 times. Steps to follow in enlargement of the map. 1. Be certain that you are enlarging. 2. Determine how many times the map should be enlarged. 3. Work out the new scale. 4. The original map can be divided into square. 5. Draw the outline of the map using this new scale. 6. Stretch the information as might have been required out of new map. 7. Transfer the new scale to the map. 8. Title the map should be clearly written. 9. The true work should be determined by the use of arrow on the right hand side. Relief representation. The term relief representation means elevation of the area. There are various ways by which land deviation can be represented. 1. Form lines are used to represent elevation of piece of land. They are usually shown by broken lines, and that distinguishes or form contour lines. Hill shading. This is a method of height representation used in hilly and mountain areas. The higher the hill or mountain, the deeper representing art. Hectares. These are short lines used on a map to show the amount of slope a land area has. In this way, where the land is high density of a hectare is given area, it shows that the place has a very steep slope. Where there is a very steep slope, where there is a low density of hectare, it implies that such place has a gentle slope. The absence of hectare means that the place is a flat land or a plain. 4. Spot hectares. Is the actual deviation of any given point or spot. 500 spot height are denoted G. Contour maps with certain spots which have certain features beside them. The features beside the spots are the actual or exact height of the ground as they appear on the map. Other like the spot height are A. Trigonometric section. B. Benchmark. Contour lines. This is the most useful and accurate method of height representation. Contour lines are lines drawn at regular intervals to join places of equal height above the sea level. Relief features produced by contour lines. 1. Conical hill. The contour line which shows conical hill, usually circular in shape, and becomes smaller and smaller towards the center, the inner contour line has the highest deviation. Sometimes a dot is used to mark a conical peak. 2. Isolated hill. This is a hill that stands apart from hill. This type of hill could be either conical or round-topped in shape. Plateau. A plateau is an extensive and broad highland area with a level surface. It usually has steep sides because of the flat nature of the top. A plateau is sometimes called a tableland. Dissect plateau is usually cut up by several streams rising from higher points and flowing in different directions. Example, Jos Plateau. 5. Knoll. This is a small hill which is round in shape. The feature that presents a knoll is usually dotted with one or two contours. 6. Ridge is a long narrow hill usually represented by a series of enlarged contour lines, and the length is many times greater than the width. 7. Escarpment or coaster. The two terms are used to refer to a hill with two sides sloping in opposite direction. One side of the contour line has a steep slope. The side having a steep slope has its contour line closely packed together, while the other having gentle slope has its contour lines widely spaced. Types of slopes and invincibility. There are two types of slope. 1. Concave. 2. Convex. Types of slope. 1. Gentle slope. 2. Steep slope. 3. Concave slope. 4. Convex slope. 5. Even slope. Types of slope. 1. Gentle slope. This type of slope occurs when contour lines are widely spaced or far apart. II. Steep slope. This type of slope occurs when the contour lines are very close to another. III. Even slope. Slopes are said to be even when the contour lines are equal from one another and they are not closely packed together nor far apart. IV. Concave slope. This type of slope has a combination of both steep and gentle slope. When ascending a concave slope, one passes the gentle slope first before reaching area having steep slope. The contour lines representing the concave slope are widely spaced at the lower level, where at the high level they are closely packed. In a concave slope, visibility is possible because somebody at the base of the slope can see another person at the top of the slope. IV. Convex slope. A convex slope is the opposite equal combined with the characteristics of both steep and gentle slope, except that the contour lines are closely packed together at the lower level, but at the high level they are widely spaced. On a convex slope, visibility is not possible, especially when the base and the top of the slope are separated by a long distance. Section drawing. Section drawing enables to bring out the true appearance of various landscapes on contour maps. It also makes it possible for us to see various landforms on contour maps as they should be in the real world. This enables us to distinguish valleys from spurs. They draw a cross profile or section drawing between 2 points. The following step can be taken. Procedure. 1. Draw a straight line to connect the 2 points. 2. Hold the straight edge of a paper along the line. 3. Prepare a graph sheet indicating the scale. Example, 1 cm is to 100 cm. 4. Transfer the height indicated on the paper to the graph sheet.